Okay, class, this is a quick review of functions and their inverses. The particular problem that I picked here is very similar to what you will see on the test. So take lots of notes. If there's anything at all that you don't understand, go see a teacher today for tutoring or see me in the morning. I'll be tutoring on Friday morning. Okay, so let's talk about what an inverse is first. Now you understand inverse operations such as addition and subtraction, multiplication and division. You know they undo each other. Well, an inverse is a function that undoes the action of another function. So when we say that a function is an inverse, one of the things that's very important to know is that the inputs and outputs are switched. So let's go on and talk about specifically what that means. Suppose I had some function f of x, and it had the input variable of x that took on the values of 1, 7, and 16. And the output values of f of x that took on the values of 0, 3, and 6. Well, if I found its inverse, g of x, the inputs and outputs would be switched. In other words, the inputs to my inverse would be 0, 3, and 6. And the outputs of my inverse would be 1, 7, and 16. Now take a good long look at this because this has lots of implications. But one thing you need to remember about functions and their inverses is that the x's and y's are switched. Now one of the things that means is that the domain and ranges are switched. That means if you know the domain of your function f of x, then to write the domain and range of the inverse, all you need to do is switch them. Now, one important thing to remember is you may go about your business of graphing a function and then switching the x's and y's to graph the inverse, and what you end up with is not a function. In other words, the x values may have more than one y value. That's not a function. To make it a function, you may need to restrict the domain of f of x, your original function, so that the inverse is also a function. Now let's go over an example of that. This is a problem from your review, so you may want to go find this problem and do it now along with this video and make sure that you understand. Now we are going to graph and label this function f of x, which is a quadratic function, and its inverse on the same coordinate plane. Start with the vertex and graph a few points on the function on either side of the vertex. Three points on either side of the vertex should do the job. You can use your graphing calculator to do this, or you can develop a little table by hand. I used Desmos to do this, and so here's what I got when I did this on Desmos. I got a quadratic with a vertex sitting at x equal 4, y equal 0. Now next I have to graph the inverse on the same coordinate plane. Now, if I was doing this with a graphing calculator, would just make a little table based on the calculator with 3 or 4 points on either side of the inverse. I would switch them and graph my inverse. Plain and simple. So during the test, you're going to have a graphing calculator, go find the inverse, and do this. Just switch the x's and y's and graph your inverse. So you see that graph here that I did on Desmos. You'll note that the domain of my original function was all real numbers, and the range was 0 to positive infinity. Also notice that the domain and range of the inverse are switched. It's easy to see with this graph. Now my domain is 0 to positive infinity for the inverse, and the range is all real numbers. All right. The problem is my inverse is not a function. If I apply the vertical line test, then I see that there are all the x values except one have more than one y value, so it's not a function. I need my inverse to be a function, so what am I going to do? I'm going to restrict the domain of my original function f of x so that when I graph the inverse, I get a function. So this is what my original function looked like. Now we're talking about restricting the domain of this so that my inverse is a function. So this is what I'm going to do. I'm going to restrict the domain at the vertex to all values of x that are greater than 4. All right, that's what that looks like. So basically, I have half of my parabola. Next, I'm going to switch the x's and y's of my function with restricted domain and graph my inverse. Now check that out. When I switch the x's and y's to graph my inverse, I end up with a square root function. That is a function. It passes the vertical line test, and voila, I'm done. Now, one thing to note is that I could have also restricted the domain to x is less than 4. And the inverse would have looked different, but it would have still been a function. Try that on your own and see. Just try it with the parent function and restrict to x is less than 0. It's easy to make a little table with the parent function x squared and then switch them and graph them, and you'll see. Now that's the end of this video. I hope that this helped a lot. If not, make sure that you see someone for tutoring after school today. Today is Thursday, or see me in the morning on Friday morning, or you can try the problem on the review. You also have a paper that we did in class with 2 of these. It would be very helpful if you have a specific question if you send me a picture of your work. I won't be able to answer until this evening, but I will answer if you send me a question. All right, peace out. Have a great day, and I will see you tomorrow.